Today we're going to be working on another Amazon's interview question. This is Leetcode question number 46, permutations. So we're going to be given distinct integer values, distinct integer values inside an integer array, and we're going to be returning all the permutations possible for that for that array of integers. That being said, we're gonna have this is what we are getting. This is what we're gonna be returning. So that's what we just created. So list of integer result is equal to new array list. We're gonna be making use of the helper function. And then at the end of the helper function, we're gonna be returning the result. Helper function has like couple of things in here. So we have the result which we're gonna keep filling in, but we're gonna have a current list of integer list where we're gonna keep adding until the size of that current list becomes equal to the nums dot length which we need. So this is kind of the base condition, and the start is where we want to have uh, this is the initial point where we want to start the picking up the numbers from. So that's the index, the start index. Okay, where exactly you want to start me to start picking the numbers. Okay, so that being said, so this is the base condition in here. So our current is gonna keep getting filled up, and when the size of that current list is becomes equal to the length, the nums dot length, we're gonna say that this is the point where, because this, we can be sure that it is a valid because that's the way we are putting it into the current list. We are already checking something, that whether or not it is still a valid current permutation, and if it is not, we are not just adding the numbers to it. That being said, we are guaranteed that at this point, the nums, when the size of the current list becomes equal to the num dot length, you are guaranteed that this is a valid unique permutation, and then you can just add it as a new array list. This is a Java thing. Otherwise it's just not gonna add it as a new list. So you have to do new array list and that current value, and then you return it. Okay, we're gonna, every single time we're gonna have, so once we are not in the base condition and we are still adding to the current permutation, now we're gonna have our I starting from that start index, and then keep going up all the way up to the nums dot length. And every single time we want to make sure that this number which we're gonna be adding, nums of I, is not already in the current permutation which we have created so far. And this is like you will see it on in all the like the helper functions for use for permutation, combination, those kind of things, that you are adding a number, then calling the helper function as an like for the iteration, and then removing a number from the end, uh, uh, like in order to achieve the results we are interested in. So again, this is an O of n operation. We basically looking at the current one, and we want to make sure we are looking that we want to make sure that the number we're going to be adding into the current permutation doesn't already exist. So we have to go, it's not a set, it is still a list, and we're going to be going through all the elements in order to make sure that that number is not already part of the current permutation. So the current permutation is we're gonna be adding that number again, helping calling the helper function again, result nums current, and this stays 0. If you happen to try, if you try to add 1 to like I to it, what's gonna happen is like it's gonna, so if you are sending 1 2 3, the only result you're gonna be getting is 1 2 and 1 2 1 2 3, the only one permutation, this one. You won't be getting any other permutations if you actually try to make it I instead of 0. This is because when you make it, you have to have I in, because we are already checking if we if we have that new number in it or not. So you need to go back, because you could have chosen 2 or 3, and you need to go back and start selecting from the first one again in order to achieve all those permutations. Okay, that being said, in terms of the complexity, right? If we don't think about the like the iteration stack uh, call, we are not really using any. Actually, uh, we are still using O of n space, because that's we have to say, like, so if we have this one, right, so the space complexity is gonna be O of n factorial, because for any n integers inside the nums, you can have an n factorial results. This is just like the permutation. Permutation has, like, if you have n numbers, you can have n factorial permutations. So I would say that the space complexity is gonna be n factorial. Again, we are not really considering any stack call space being taken by because of this iteration again and again. Uh, so in terms of the time complexity, the complexity is gonna be n factorial, because we are gonna have n number of elements, so we can have n factorial permutations. And apart from that, we are also doing a lot of for loops. So we have one for loop over here, and then this contains also goes as an O of n operation, so maybe an O n square, or it could be O of n cube too. But remember that n factorial permutation plus O of n square or n cube still remains O of n factorial permutation. Reason being, n factorial permutation is such a big time complexity that if even if you have O of n square next to it, still the total is gonna be like O of n factorial. Okay, that's it, guys. That's all I wanted to cover in this video. Thanks for watching.